Evening. How are we all doing? Yes, I will be doing some electrical stuff today. Yeah, don't worry. I know very little about electrical engineering, only what I've read, so don't expect it to be perfect. Don't know. What does the sound like? Indeed, indeed. Oh, so it's either a bong on my desk or it's my shrimp tank. Hang on, let me adjust the air hose a minute. Sorry, shrimp. There. Is that better? Good, good. Everyone needs a shrimp tank on their desk. Dev snacks. If I get peckish while I'm deving, I can just reach in and grab a shrimp. Good, good. Okay. Let's get rid of my ugly face. Where are we? Where are we at? What are we doing? Can't remember. Yeah. I need to get a new logo. No, this is just a t-shirt. So I've been doing a bunch of debugging because I've noticed our tick budget has gone up a bit more than I wanted it to. So I've been going through and just getting rid of a bunch of unnecessary stuff. Like it's lots of silly little things, like on the NPCs, for example. One of the things we do on tick is we just rotate the nameplate to face the player camera, so that their name tag's constantly facing the camera. And it was doing it even if the NPC was miles away on a different deck. So we're wasting CPU budget on all of this stuff that we've been doing absolutely needlessly on the NPCs. So it's good practice just to keep profiling, to keep going through it and keep knocking off stupid stuff like this, which is costing CPU budget when it need not do. Alright, so let's grab our Caravella. Really need to put the ring on it at some point. Basically, yeah. Yeah, and collapsing all the UIs down to a single pixel, because with the way that widgets work in Unreal, they use a render target, and obviously that render target is held in VRAM at whatever resolution the render target is. So even if the widget's not being rendered, it's still in VRAM at the size that the render target is at. So by collapsing them all to 1 by 1 pixel, you free up VRAM. Especially when you're widget heavy like we are. So on our Friday stream, last Friday I think it was, we were experimenting with the electrical cables and getting them working a little bit more responsively. So moving away from the event-driven process and making it a little bit more tick-related. To have just just faster convergence times, really. So it deals with faults immediately, because if the signal doesn't get through, then the fault is definitely there. I think we'll have a hybrid system when we're done with it, so it will send like keep alive pulses, but ultimately still be event driven, so that we're not absolutely ticking everything once per second, maybe once every 30 seconds, just to make sure that everything's still converged. But we'll see. We will experiment with it. But what we start needing to do for the Caravella is, at the moment, all of this lighting is just working by magic, because we're just pretending it's got voltage. So we need to actually lay some cables, put some hardware in, and start actually giving things voltage. Now, we started off with our reactor, and we started adding a bunch of our coolant loops and our fuel loops. So that should be working now. So the next thing we need to do is we need to start handling getting voltage through to these batteries that either are or will be in here. I think I took them out because they were moaning about some stuff. Yeah, run the cables up this stairwell and then start breaking out into the individual decks. So if we hop across to SketchUp a minute. What? Be gone. What an exciting white screen. Right, it's been a few weeks since we've been doing this, so let's kind of remind ourselves of where everything was routed to. So we were working on the model that we've got all the supply cables to the battery arrays there. So we've got one of those per array, and then the output from those going from there to wherever it needs to go. So we need to take what we've done here and then start moving that actually into Unreal so that everything is properly wired up. But I want to kind of start as we mean to go on with it. So I want to move away from typing in manual names for everything. Hang on, lost, where are we? Here we are. So again, with these cables, we are typing in the name of the cable manually. We're typing in the name of the device it connects to manually. And when we start rolling this out properly, that's not feasible for the amount of cables we want to do. So we need to touch tips and get them to sense each other. Now I don't want to run the full cable run yet, so I think what I'll do is maybe export them, probably export them just in their basic form. So if we take each of these cable runs and combine them into a single object, and then I can just stick the meshes on the end for end-to-end connections. This is going to be a little bit confusing for a while until we've got the infrastructure kind of set up the way we want it. Yeah, so the way it's going to work in terms of the electrical distribution is the reactor cap at the end here. Basically, we take the pressure against the magnetic field of the fusion reactor, and we turn that pressure against the field into electricity. So we're using direct energy harvesting, which means that we can control how much voltage goes out of each of these connections. We'll make this obviously a lot nicer when we actually model it properly, but the idea being that each high voltage feed will have a separate feed going into the reactor, and the reactor will be putting a certain amount of voltage on that cable. Now once that voltage has been established, there's no need to do anything else unless that voltage changes for some reason, which keeps the whole thing event driven. But Unreal being what it is, and networking being what it is, sometimes the message might not get through the first time. So again, under high latency conditions, or if the loading screen's laggy because you've got low FPS, we can come up with instances where that initial signal never makes it all the way to the endpoint, so the end device never turns on, because as far as it's concerned, it never got voltage. So even though the reactor said, here's some voltage, some things don't get it. So we need to make sure that periodically we send an update pulse just to say, this is still the voltage. So it's a case of how often do we need to send those update pulses, in addition to the actual condition changes that we send down the line. So basically we need a keep alive pulse. Now I think the reactor's ticking regardless, just to make sure that it's not skipping anything, but we need to carry that down the line. Yeah, so a lot of it's already working like that. And then we have two-way messaging, because we need to also report usage. So the cable needs a way of knowing how to calculate the amperage, and the only way we can calculate the amperage is to know what the wattage is at the other end. So we take our voltage, we have our wattage, our combined wattage from everything that's using it, and then we work out our amperage from there. At least I think that's how we did it. I can't remember now. It's a long time ago. Which one to do first? I suppose the practical thing to do would be to get the batteries themselves charging, because once the batteries are charging, then we can start distributing voltage from there. I mean, the high voltage systems, they're direct feeds anyway, so we can perhaps skip them for now. Because we also need to make some capacitors for the FTL drive, which need to be fed directly by the reactor, and then we need to go through a charge sequence on those before the FTL can be activated. Right now it's just working by magic. It does react to the amount of voltage coming out of the reactor, but there's still a lot of magic going on. We need to make that a lot more hardware driven. Yeah, well, we can send and receive any data we want, really. It's just a case of what is prudent at the time to keep everything performant, because obviously the more you're sending, the more you're costing CPU time, and we want to keep that to a minimum. Okay, let's start off with those batteries, and have a think about what cables and why. And do we have a distributor in here with a single cable, or do we have multiple feeds coming up there? So I'm tempted just to go with the multiple feeds, because otherwise we're very light on cabling, and it looks a bit barren. So deck 1 power, and we need some batteries. Everything is on the server side, so the client's doing nothing. So the only thing the client actually needs to know is whether or not a light is on or off. So the client doesn't need to know what the cables are doing beyond how much voltage is on them. If they use like an engineering tool on a cable, they need to be able to have a report back for things like voltage, amperage, and such. But that doesn't need to be replicated until it's needed. So the actual simulation is running on the server only. And then the state of a light, whether it's on or off, is the thing that we're replicating. Yeah, I've basically just got lots of spreadsheets first with all the calculations on them. That's kind of how I do everything coding wise. I always do it on a spreadsheet first, and then once it's working on a spreadsheet, then I take it in game. We're going to struggle to fit in the 4 that we need here. I might have to make some different meshes for these ones. I think for now we'll just stick them all together, overlapping if need be. Obviously it's a much smaller ship, so we'll have to make probably thinner but taller battery arrays, and probably floor to ceiling as well. So we'll just have long rows of batteries that you walk between and remove as required for repair. We can stack them, yeah, so it's more just about having room enough to have the UIs so we can see what the batteries are doing. And then for the actual units themselves, we'll just go all the way to the ceiling and just have row upon row of batteries, like bookshelves basically, just with batteries. And we need to make sure we've got room for crew members to get round to the back. I think what I'll do is I'm going to basically I'm going to do duplicates of the existing hardware, because I want to make some modifications to how they sense their connected cables, and once I start doing that, it's going to break the old functionality, and we don't want to break the Magellan at this point. So we'll get it all working with the new hardware on the Caravella, and then I can just swap out on the Magellan when it's all tested and polished. Yeah, so we'll replace those with the tickable ones. I say tickable, but they're not actually going to tick. Okay, and then what we want to do with these, so rather than going through our cable sensing. Where is it here? Yeah, so what we're doing is we are recording the name of a cable, we're looking for actors that have that tag, and then we're setting up a reference to that cable. So what we want to do instead is take our actual physical meshes and see what they're overlapping. I think we'll continue to check whether or not we're actually using this interface, because if we're not finding something, we're going to have to keep retrying until we do. So if we're not specifically using it, we don't want it to be just like looping forever looking for stuff. So I guess we'll keep our timer, and we'll use that for our loop. So we don't want that. So upstream would be in, wouldn't it? So we want our input cable. Not sure what you mean, Adam. Surely, in order for the game to be released, you need to build the system for the electrics. You wouldn't want to do it after the fact. But yeah, so the system needs to support dynamic environments in the future. So at some point, we want to be able to unplug cables and maybe cross-wire something from somewhere else. So if you've got like a faulty unit, you can unplug a cable from one, reroute that somewhere else. So we need that physical knowledge that something has been plugged in. And also, if we move to a modular shipbuilding system at some point in the future, we want to do the groundwork for that now. So when we're building modular ships, we just need to bolt those prefab pieces together, and they'll just instantly work, because we're detecting connections rather than logically looking for named interfaces. Yeah, we're definitely not taking the Star Trek approach. Doing it for reals. Okay, so we need our valid classes. Although saying that, we won't need that on this one, because the only thing that this is ever going to overlap would be a cable. So we don't need to worry about having to overlap with different classes. On the cable, that can overlap with lots of different things, i.e. whatever you're plugging it into. So we'll just have a single class for now. So, is that a valid index? If it is, we will get a copy and assign that to our cable. So now we know what it is, and then we'll get rid of the timer because it's no longer needed. Otherwise, we will just do a bit of spam. So that we know that it's not finding something and we need to do something about it. Although I think I will use the actor name. Because then we're not having to specifically name things. I think we'll keep a name reserved on the cable, because at some point we are going to have to reference these cables for fault repair purposes. And I think what we'll do is we'll inherit the segment name. So where we've got, I guess not quite so obviously on this ship, but where's the corridor? So where we have the segmented corridor like this, then each individual cable will be in one segment. So the segment label for this corridor, then the cable will inherit that same segment label, with some kind of additional modifier for things like is it for the electrical system, is it for the hardware, that sort of thing. But if we're going with segment numbers, then we know where it is on the ship. Do you mean that that universal prop, Jason, the one that's been used like in every sci-fi show ever? It depends on the ship and as to how we label things. On this particular ship, we'll probably go with either just fore and aft, or we'll go with the segment numbers. So we do have frames that we're building in isolated sections, so that would be frame 1, frame 2, frame 3, frame 4, and so on and so on and so on. I guess from shipbuilding parlance, then you'd treat each one of these as a frame, so you'd have frame numbers going all the way down. We can do that. I guess for a ship of this style, frame numbers would make sense, because we do have lateral frames going all the way across. So we can use that as part of our naming convention. On the Magellan it's different because it's circular, so we use radial references on that. But I think, I think frame numbers would work, because real-world vessels use frame numbers. So I see no reason not to. And then you just have frame number, deck, port, and starboard. I have indeed, Frasser, although we did this a good few weeks ago. Yeah, we spent a couple of streams working out where the cables actually need to run to, and then and then we'll start routing them properly once we implement them in engine. If you've not heard of it before, Myriad, then that's Claire's fault. Although she does spam it on social media everywhere. Right, so we need to do the same for this one as we did for that one. Grab that. Borrow that. So if that is a valid index, then we'll set a reference to the cable, and then we will get reference to ourself. So essentially we're doing the same thing, that we were already doing, but we're looking for an overlapping connector rather than trying to find something via an ID, which ultimately is just a lot less of a headache to set up, which means that we don't need things like, don't need that. Where are you using it? Okay. Right, so the UI screen on the battery does report things for the cable. I think we'll probably just either put that in manually or we'll grab it from the cable itself. When are we doing that? So we're doing that before we set these up, so that means that won't be a valid reference yet. I'll come back to this. We'll find a better way of doing that. I think what I'll do is I will grab a reference to the cable and then pull the name off of whatever we've configured on the cable itself, so that we're not having to kind of guess at what it should be. We'll take that directly from what it actually is. That's the best way of doing that. I'll leave it for now. Doesn't matter for the minute. So then, our first of many exports is going to have to be probably this box here. Yeah, then we've got that connector, which is coming from there. Then we've got these four, one for each array. Goes to there. Oh, that's it, yeah. And then we were doing two sets of batteries per side of the ship. So basically you've got these two power the port side, those two power the starboard side, so that the port and starboard electrical grids are physically isolated from one another, which is a little bit confusing when it's a single room that spreads all the way across, but we'll favour one side over the other when it comes to that. Yeah, everything is based on volts and amps. The battery simulation it's not going to be 100% real world, so we're not going to do things like as battery charge reduces, voltage reduces. We won't be doing anything like that. So we'll have a set output voltage from the batteries, which will remain the full voltage until they die, in which case it just drops immediately to zero. There's some kind of futuristic solid state battery, basically. We're also we do need to do some energy density calculations. We've done it for the reactor, so we know in terms of cubic volume of plasma, we know how much energy we can generate from 1 cubic centimeter of plasma. So we can scale our reactors based on that calculation. So the more output we need, the more cubic centimeters of plasma we need, therefore the bigger the reactor chamber needs to be. So we've done that. So we should probably do the same for batteries, where we're working on what is our energy density for each battery device. So we'll do the same thing with cubic centimeters. So for every cubic centimeter of battery, how much energy are we storing? And then we know how big the batteries need to be, and thus how much storage they're going to take up on the ship. We can't do that for everything. Like, I was working out, like, when it comes to the hydroponics and the farming, like, how much hydroponic space would you need to feed a crew of 200? And it turns out you need an area of fields like twice the size of the ship. It's ridiculous. But for things like this, we can probably be a lot more realistic with it. Yeah, there's probably depth that we can go to with a lot of things that we won't do, because ultimately, you know, the point of this is to provide meaningful simulation for the game, and things like heat loss, for example, that's something that's kind of beyond the scope of the game. We will do heat for cabling, so obviously if you over amp a cable, it's going to get hot, and eventually it will catch fire, and then that's how we can have short conditions and fire spread on the ship, because things are getting, you know, over amperaged. But we won't do things like having the temperature of the cable affect its conductivity or anything like that, because that's beyond the scope of the game. It's like it's taking the simulation to too much depth, like beyond the point where it's meaningful from a gameplay perspective. We have to draw a line somewhere, basically. What was I doing? Cable, right. So if we do the reactor one first, actually, because we need to actually power the box. So for now, I'm going to make all of these extremely basic. So I'm just going to shove that in there. Job done. And then what we'll do is we'll group that up as a cable, and we'll export this cable as is, which means that for some cable runs, we'll have a pre-made cable. Obviously, we'll make it all nice and properly rounded. For cabling running down corridors, then we'll just have single segments that we can copy paste in Engine. Places like door frames will probably have a pre-made, like up and over a window or up and over a door frame sections that we can pull in. But yeah, a lot of it is going to be proprietary meshes. Which means we also need to come up with a good way of naming some of this stuff as well. Start as we mean to go on. Yeah, exactly, with the hydroponics. We are using some kind of future crop. I mean, we could use like some kind of a moss, maybe. But essentially it's just raw plant matter which gets mushed up and turned into pellets for the 3D printers. That's one aspect of it, Alex, which has actually always confused me. So I still haven't got my head around the whole joules to energy conversion. So obviously we've got our voltage, our amperage and our wattage calculations, and obviously joules do factor into that. But like when we do the batteries are storing, I think it was voltage. I think I was like the unit, we're not using like joules as a unit of measurement, whereas really we should do. And then you've got things like watt hours, and then how do you determine the capacity of a battery, or rather how much charge is remaining if you're using watt hours, because then watt hours depends on like how much voltage you're drawing. So the actual capacity remaining changes depending on how much the draw is. So it's a very confusing thing to get your head around. Like I said, there are definitely limits to my knowledge, and that confuses me. But yeah, if you want to base it on joules, then that's probably the base unit we should be using in terms of a way of expressing energy. Yeah, so the UI at the moment basically tells you time to depletion based on current charge. Yeah, please do. It's one of those things that's never clicked in my head. And funnily enough, it was the batteries that were giving me the biggest headache, and just a way of expressing the different terms when it comes to batteries. Yeah, I guess batteries are quite complicated when it really comes down to it. Yeah, definitely keeping static voltages. We don't want to fluctuate that, because that's going to cause many other knock-on issues. Yes, don't ignore the wife. Never ignore the wife, as I'm sure Claire will agree. I'm going to have to come up with a naming convention for these, which makes sense. I suppose this is reactor output. Batteries. There's only going to be a few reactor output cables, so that should be fairly unique. Yeah, frequency and timing is another thing that I've just completely skipped over. I watched a really cool video once of like a hydro plant like syncing up voltages to go on the grid. I think that's what they were doing. So they were basically putting the hydro plant on the grid. In order for them to do that, they had to get like the sync times like nailed the same. So the guy that was doing it had to wait for the needle to be exactly, and then you can like pull the big lever and it goes chunk and everything goes across. It looked quite exciting. Like, because if you get it wrong, then you've got to shut the whole thing down and start again. It's the kind of thing that would make for good gameplay, I expect. Right, So Caravella meshes. Hardware. Okay, so what did I do? So we went electrical, then cabling, trying to keep the folder structure the same, both locally on the hard drive and in game. So Caravella, hardware, electrical, cables. Oh, I call it cables, not cabling. Okay. Okay, so on the fluid one we'll have like valves and things and then pipes. And on this one we'll have electrical hardware and cables. So the other thing we will do with pre-modeled cable runs is we'll use these on a smaller scale for generating the 3D model of the electrical system for the holo display. Because that's one of the big things about the engineering systems is having the whole ship visible in 3D so that you can actually peel away the layers and look at like just the electrical system in isolation and actually see like this linkage like flashing red because there's something wrong with it. So having all of this as static meshes already will actually help with that, because we can just scale it down and apply different materials to it. And although I might do a lower poly version of it, although with nanite that's not necessarily neat. Actually no, there's no point, because so one of the beauties of using nanite is that so we'd have a relatively high poly mesh for representation in the game world, and obviously that takes up space on the hard drive, but we can use the same assets and scale it all the way down for the holo display, but we don't need to author another asset that's low poly because nanite doesn't care about the amount of polys, so we can just not use up any more hard drive space and just reuse that asset, which is just a nice pipeline advantage. Literally a pipeline. Which material will I be using? It was that one, wasn't it? Where are we? That one. Back mesh collisions will be fine for this. Different aspects of the ship have different voltages, so I guess the domestic grid for lighting and doors and just stuff on the interior of the ship is going to be on a domestic voltage circuit. So we might go to 40 volts, we might bring it down a bit depending on the need. So that's just like domestic electric. When it comes to the high voltage systems, obviously we need to supply a lot of energy to those systems, which means we need to crank the voltages all the way up to keep the amperages down. So as my small, untrained brain understands it, the higher the wattage of the end device, the higher the voltage you need to give it. Otherwise, amperage is going to become a problem. So you need to keep upping the voltage to keep the amperages reasonable. And obviously there's only so high you can go with that before the voltage is so high that you're then arcing. So we need to balance arc distance with voltage and amperage so that the amperages are staying reasonable, the arc distance is not going beyond the sheath of the cable, and everything should add up and work. Should. And yes, the food stock on the ship is just biomass. So the organic 3D printers convert that biomass into like facsimiles of steaks and sausages and potatoes. So I'm not bothering to set up like snapping distances or snapping points for these cables yet. I'm just going to export them at their world origin, so I can just place them at 0, 0, 0 and they'll be where we want them to be. In the future, I will make them, or I'll give them their own world point, and then we'll have to position them more carefully. So this cable here is what we now need to replace on here. Because this device is ultimately looking for that cable, so we need to make sure that it's now capable of using the connector to identify that cable. So I suppose we need a, yeah, we'll use that one and make sure that we can move these around. So we don't want any of the spline stuff for this one, because these are all going to just be plain static meshes. We'll keep the label name. Okay, so spline, 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 spline. So we don't want any of that. So we'll add our cable mesh. Which we have a variable for it we don't need, so we'll get rid of that. Right, so that's all spline stuff. That's all spline stuff. That's spline stuff. Don't need that. Don't need that. Don't need any of that. Right, so that's just scaling our pipe end pieces. It says pipe. That's because I use this for the pipes. Yeah, and that's just setting our draw distance for optimization, so they can stay. We don't want that. That makes life easier. be honest, we don't need that either. We'll just plug that in there. Because we're not dealing with dynamic cables on this one, we don't need that either. I think I deleted the rest of the stuff we didn't need, so that's fine. Okay, so without all that spline stuff going on, it means we'll be able to move the two end pieces to where we want them. And then the awkward thing with this is that they're going to be miles away. Hum. See, what I could do, actually, if I use the socket as a snap point, and as long as that box is in the right place, then I can just snap the cables into it. But that does mean that the box needs to be in the right place, like exactly on here for it to all line up. Which I could do. Yeah, I'll have a think on that. Right, I suppose we need a variable for our mesh. Which we apparently already have. Okay. I'll just repurpose that then. Where are you in use? So if we get rid of that, and then we use that instead. Okay, I'll have to redo those for a static mesh, but that's fine. We'll just skip that for the time being. Basically, we generate different size and graphics and things depending on what type of cable we're using, so we can reuse the same actor and just scale everything as we need. Although to be honest, we won't need to rescale this one because we're using a static mesh anyway. Yeah, it is fine. Oh, forgot to set myself to do not disturb on Discord, so that ignore the ping, that was me. Ah, Mr. Seeker, thank you. Okay, I'm now on Do Not Disturb. I know. I'm always forgetting to do that. I'll just define that on the construction script, which means that needs to be instance editable. I guess the other things we're not going to need is the name for the upstream and downstream device. So they can go now. And then we'll also have to work out which interface we're actually plugged into on the device at the other end. Because when we're sending voltage down the cable, we need to know, which plug it's plugged into. But we shall cross that bridge when we come to it. Okay, so this was Caravella cable, that one. That's weird. Why is it putting it over there? Don't know. Oh, it might be a scale thing actually. Let's skip the scale thing. Oh no, that's just the interfaces. Scales 1, location is the world origin, which means that should not be there. Just trying to work out why the world origin is not where I thought it was. Oh, yeah, it's there. So let's grab that a minute. So that's our world origin, which is where that little block is. Okay, so they're definitely aligned. And that's definitely there, which is in line with where the plug is. Okay, confused. Yeah, sorry Grimlock, it's just me trolling everyone. Right, so yeah, it's definitely in the right place. So why is it not in the right place for that cable? What are we missing? So blah, 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 blah. Right, so that's definitely at the relative local origin. Can be set to static. We're not doing anything here to move it anywhere. Yeah, all we're doing is just setting the mesh. Set that as a engine cube just as a default. Actually, on that note, if we set that to a cube, where is it putting it? So it's putting the cube in the right place. That's really weird. Like, the only reason it could be somewhere else is if the location was wrong there, which it isn't, or its scale was off, which it isn't. Huh? Because its origin point is there, like the actual mesh origin is there as well. Because if I move that out of the way, okay, so it's the right height vertically, but it's off laterally. You ever have one of those times when nothing makes any sense whatsoever? So it's not rotated, but it's off a little bit on the y-axis. Hang on, is it off by the same amount on both? So it should be about there. That does look a bit bigger, actually. Yeah, that does seem to be what's happening. See, that looks bigger, although it's hard to tell actually because the box is in a different place. But because if we're setting it there, yeah, there, just above the door, so it's off by that much. I'm thinking it's a scale thing. Oh, it is a scale thing. Look, there we go. It was the scale of the actor itself, not the mesh. Huh, weird. Right, everything makes sense in the world now. It's all good. Phew. So this will be easier when we actually connect it all up properly, but for now I'll just move these interfaces around into place to force the overlap. And these do need to be separate objects. Well, they say they need to be separate objects. I guess technically they don't need to be separate objects. Because we don't need to necessarily overlap a component, we just need to overlap the actor. So so we could make that part of the mesh, in which case, if we are doing that, that does define where precisely this box needs to go. But like that should do, overlap wise. And then the other one needs to go over here. And again, on the reactor itself, the reactor is going to need some outputs. Ah, Sophie, thank you. Very much appreciated it. I need it tonight, I think. I seem to be going a bit mad. Right, yeah, so the reactor is going to need... Just wondering whether I make a duplicate of this one as well, because we're going to change... Okay, I already did, so that's fine. Yeah, we need to change a couple of bits about this as well. So, like with the cables, we need to do our overlap check. And we'll do that on begin play, not on the construction script, because I noticed that doing it on the construction script was quite inconsistent. It definitely wasn't consistently getting what we needed it to get, so which is fine to do it on here. And then we also need, what else? There's a few inputs we're going to need above and beyond what we've got, and also we're going to need multiple reactor outputs now. So so we're going to have a lot more in the way of input and output. Very true, Madman. I think I should rename myself to you. it will all make sense. So I already made a bunch of connectors, which are probably hiding in here somewhere. Where are they hiding? They're hiding somewhere. But we need to copy, I guess if we copy those ones, just use the same mesh. This one's easier because they don't have to move as far and they can stay part of the actor. So we'll keep that one at the midline. So the point of this, obviously on the final version, is there's going to be like a distribution cap on the end of the reactor, and it will have lots of different connectors on it for all the different types of cables we have. So they're going to be, you know, smallish ones for things like charging the batteries, and then some really, really massive ones for things like the FTL ring. And then we've also got our inputs, which I guess we can just stick underneath. I guess we'll keep them at the same end. So if we pop that down there, because we have the start capacitor that we need to plug into this reactor, so that's going to have to factor into this as well. Right, so simple plug there for power in, and then a simple plug there for power out, and then we'll add and scale more of those as needed. So that kind of approximately lines up to that. And then for now, with our cable, we'll simply move that over there so it overlaps. Doesn't need to look pretty for now, we're just testing. Right, so that cable can go. So this being our first downstream connection, we will use this one. So same as before, we will get overlapping actors, and it can only ever really be a cable. And then we need to know whether or not it found one. And then if it did, we set our reference there. Clear the timer. Otherwise, we will whine about it. So that gets us our cable connected. Let's just see whether or not we actually still have connectivity there. Ah, I forgot we were in a field of potatoes. I need to change the debug teleports actually, so that we can teleport around the Caravella rather than it thinking we're on the Magellan. Okay, so the reactor is still working, which is nice. So if we switch that to supply, then that cable should be lit, which it is not. So it's basically saying no load because there's nothing on it, there's nothing drawing it, but we should still be applying a voltage. Okay, so the internal bus is doing what it should be doing. Yeah, I suppose that makes sense. But yeah, we're not putting anything on the supply. Okay. So this is where we have to troubleshoot. So on our reactor tick, we go through all the shenanigans of working out are we errored or not. Yep, okay. Blah, 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 blah. Okay, that's just doing the cable, so okay, so we should be sending voltage on that cable. Let's just grab a copy of that. Let's see how much voltage we're actually outputting. And the other thing we'll do is don't want our NPC, but if I grab our character, then we'll set up those debug teleports so that we can teleport around the ship in a more proactive way. So the destination of the teleports basically needs to be ship dependent. So if we get our player controller, okay, and then we need to get current vessel. So that tells us what ship we are currently on, or the shuttle. And then we need to then do a select based on that. give me the vector input pin. Right, so there, there, and there. Right, now we just need to know what locations do we need to set for the Caravella for each one. So position 1, I guess we'll stick on the bridge. That's no good because the origin point's on the floor. So if I grab our character, because the origin point's in the waist. So we want to be facing that way. That'll do. So there. There. And rotation can be the same. Although we might need to do the rotation based on ship as well, but should be fine. Fine for testing. So this is going to get kind of annoying because it's going to be a lot of blueprint spaghetti. I think I'll, I guess, condense these down a bit. And we don't want to do that. So right now, to exit a planetary surface, we're using the debug teleport to get back to the ship, which is setting our current vessel to 0, which we don't want to do for this. So I think what I'll do is I'll connect that to the emergency teleport instead. So to get back from a planetary surface, you'll need to use the emergency teleport rather than the debug teleports. Unless I just make another one. I could do that, to be honest. I will do that. In addition to that. Okay, so Alt 8 will take you to the bridge, whereas the the emergency teleport will take you to deck 2. I'll make sure I put that in the notes. Right, so that means that this is now isolated, so we can collapse that. Yeah, it's just really warm on the bridge. Everyone strips down. Not yet, Anasi. That will be coming at some point, though. Right, so to be honest, we can just do that. That's weird. I wonder why this wouldn't allow me to use that input. Because it is the same player controller. Huh, weird. I wonder if it's because it's in a collapsed node, it needs to redo the cast. Blah, 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 blah. Yeah, to be honest, it won't hurt just to duplicate this. Make life easier. What's the most useful place on deck 2? I guess that's where the captain and exo quarters are, so maybe if we make the deck 2 teleport down the corridor there. Okay, so I can get rid of all of that. And to be honest, if we're doing that anyway, just for consistency's sake and all, we may as well just do that. Gets rid of a couple of inputs. And that one, that can just go in there as well. There we go, even cleaner, one single node. test those out a minute, make sure everything is still working. Then I'll well, I only need to go down to deck 4 really for this one. No idea, Anassi. Right, oh, oops. Okay, so it's putting us in the middle, which means it doesn't know what ship we're on. Okay. Which is odd, actually. So when we start a game, we should be telling our player controller what ship we're on. Yeah. Ah, because it's 2, not 1. Right. Right. Of course, I was setting the shuttle for 1. My bad. We need to work out what the shuttle equivalent of that will be. Probably we'll set them to the same place. These debug teleports will of course be removed once we go into like proper early access, but for now they're just for making QA work and troubleshooting easier. Okay, 1. So 1's working, and Alt 2's doing nothing. 3's putting us there, 1's putting us there. 3, 4, 5, 6, 7. And 2's doing nothing. Alright. Oh, that'll be why. Okay, well we know that works, so we shall continue. Okay, so I guess for deck 3, okay, so if we go to here, then that takes us either to the shuttle bay or into engineering. So we'll move the guy over to there. I think there's a... Is there a snap to camera? Move object camera. Yeah, there we go. and then make it invisible apparently. That was hardly where the camera was it? Okay, that'll do. The reason I'm going through this seemingly pointless activity is to make testing this stuff quicker. So we can open it up, teleport to wherever we want to be, without having to run through the ship every single time. Okay, so Alt 3. Of course, I didn't hook it up, did I? Don't know what is going on with my brain tonight. Oh, and of course, let's make sure I get that one right as well. So that was minus 600. So Alt 1 for the bridge, Alt 2 takes us down onto there. Still, why is it placing us in the wall? Weird. And Alt 3 also is placing us in the wall. Right, I know why. Because I think it's setting the ship ID. At least I assume that's what it's doing. Yeah, it is. So, yeah, that's what we were doing wrong there. So, because we were setting the vessel ID to 0, it was then trying to teleport us to the location that we would be at if we were on the Magellan, which of course we don't want. Okay, Alt 1, Alt 2, which is correct. So that's putting us here, which is a useful spot so that we can test those rooms and such. And Alt 3 takes us down to there, which is useful for this bit and useful for this bit. Perfect. Right, so for our next fun task, let's get the reactor back up and running again. So we don't have So reactor can't find its interface 1 downstream cable. So basically it's saying that overlap's not working. Okay, why not? So cable tickable, make sure that's the right thing. Cable tickable, yeah. So downstream, which is the out interface. So it's saying that it's overlapping with nothing. So, and we know that is that set up with collisions? No, that doesn't help, does it? Yeah, to be honest, they can just be set to block all. Yeah, so reactor's still complaining. So, yeah, so they're set to world static. And they're also set to world static. So that should be fine. And it's these ones we want, of course. So block all, world static. Okay, so we don't need to worry too much about what this one is grabbing. So we're not checking an actual actor type, literally. Just do we have an overlapping actor? I'm going to add a couple of different classes to that. Or, actually, if we clear that a minute, so it overlaps everything, then what we'll do, we'll just get we'll loop through them and see what it's actually overlapping. Now we'll just grab a name. Make that a different colour so that we can see it and make it hang around a bit longer. and at the same time the batteries, just going to disconnect the loops on those so they stop spamming the screen, which of course they're not going to like. So that means that the reactor isn't overlapping anything at all, which is odd, because it definitely is. So interface out is there, and it is most definitely overlapping. And it should also be overlapping that sphere as well. Nope. Okay. What's going on with that then? Right, so we're definitely dealing with the right blueprint. Definitely running this. We're definitely using the right connector. Interface out. There is only one of them. Okay, so that's definitely enabled. Generate overlap events is set to true, and it should be the same for the cable. Yep, so generate overlap events is true. It's doing a weirdness. So on the cable we're using that one instead. Let's try doing it a different way. I'm wondering whether it's not liking using a component. Do we actually need to give it the transform? Okay, let's see whether it overlaps anything now. Yeah, there we go. So it doesn't like the other node for some reason. Right, so you can go back in there, you can go back in there. We can set that back to cable because we don't want it to overlap anything other than cables. Okay. Yeah, so I was doing it slightly different on this where we're checking valid classes. Because we're going to have to report back load on the cable back to the reactor. So we're going to have to add the reactor on here. If we spell it right, that usually helps. So we should grab that reference. Basically, if we get flashy lights on the cable, then we know the reactor is outputting correctly. This thing working again. Fix our colours while we're at it. Right, so stick that on there, stick that on there. Right, okay, so we're seeing voltage now. So the way I've got these actors set up is, although it knows it's sending 10 megavolts out on that link, it doesn't record it unless the cable's actually reporting that. So, so this is basically what the cable is saying, not what the reactor knows about. Because from the reactor's perspective, you know, that's its internal bus. So, you know, the assumption is if that switch is closed, then there's going to be 10 megavolts on that cable. But from the UI perspective, it waits for the cable to update it to say, yes, I'm receiving this much voltage. So that is now flashing, which means it's working, basically, which is good. So now we basically need to just continue that along. So we can get rid of that. Is that a child of, yeah, that one. So I'm going to make a different version of this as well. I guess we'll just replace it with that one for now. Make it dynamically scaled. Right, so we can edit this one and not affect the rest of the ship, because we don't want to be breaking anything on the Magellan. Not yet, anyway. Blah, blah, blah. Right, so same deal again. So we do a lot of work on here to sniff out what's connected to it. Which again we skip if we know there's nothing plugged into it. At some point in the future, we're going to have to have all of them doing a check every so often to see whether anything's plugged into them. But for now, we'll just do this. Yeah, because basically they're doing it once and then giving up if there's nothing connected. Because one of the issues we were having is that because we're using, or we were at the time using get all actors with tag, running that like every 1 millisecond or 10 milliseconds was obviously quite laggy. So we don't want to do that if we can avoid it. Okay, so where is interface A? So that's part of mesh. One, two, three, four, five, six, 7. Oh, they must be overlapping. Okay. So we don't actually have any input interfaces. They're all output ones. Which one's that using? Okay, so is that something that we've added to this one? Yes. Which we don't have on this one. Okay, so let's make some of these as well. So we'll have our inputs and our outputs. So we want our 5 centimeter connector male. Those ones need to be that way. So we'll position these as needed. These higher voltage ones will be bigger than this, but for testing purposes that will do for now. So that's interface 2. I'll add a few more. because if memory serves, I set this up to use multiple inputs and multiple outputs, so that we could use the same basic box for any particular reason. So 1, 2, 3, 4, 5. Yeah, so there's six that we're catering for inputs. But if we have like lots of inputs and lots of outputs that we're calculating in the back end, then we can turn those on and off per device. So we can have any flavor of distributor we want with any number of inputs and outputs, and then we can just use the same base class for all of those different devices, rather than having to create a new class every time for each one. It just keeps things more efficient. And then I guess for all these other ones, we just need to kind of move them out of the way a bit. We'll hide any of the ones that we're not actually using. Okay, so this box is probably a little bit on the large side. So if we go 50 by 50, and probably actually a bit taller than that. I need to also do dynamic top and bottom on this as well, because again, if we're using the same actor for whatever we're doing, then we need to be able to choose, where are we putting connectors. We need some that come in one side and out the other. We need some that come in the top and out the side. So I shall add static meshes for that. Right, so specifically on this one, so we need to hide the ones that are not in use, and then the ones that are in use, we shall pop there, because this one's going to be fed from the top. I don't know where it went then. It snapped. Right, so that would go somewhere like that, which means the connector from this one needs to overlap that in order for them to see one another. Again, this is just a test. Thank you, Archer. So I guess another thing we need to do with this is dynamic UIs based on the arrangement of the things that we want for this particular device. Because what I have been doing is for every new distributor we add, I'm having to build a whole new UI for it. If we could get them to automatically scale based on the size of the box and how many interfaces are in use, and indeed where those interfaces are, that would make life a lot easier. Because they could move the UI graphic from like that side to that side, and if we're in a situation where we're having to deploy a lot of these, that will really, really help. Okay, so we wanted to hide any of those that are not in use, and we should be setting those yeah, here. So B, C, D, E and F are not plugged in. A is plugged in, which is that one. And on the output side, 1, 2, 3 and 4 should be plugged in, and then the rest not. So from the device perspective, so we're setting draw distances, blah 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 blah. That's handled separately now. Okay, so really we could do with maybe a little macro for each of these static meshes, where we can check things like draw distances and such, and scale as well. So if we're scaling the cable, we can handle that via the macro too. So if we grab that, okay, so we want to set, oops, no, not that one. I'll set visibility, and then we want to set our draw distance, and we also want to set scale. Okay, so if we make that a macro, configure connector, that'll do. And then for inputs, we need an exec pin. Yeah, then I guess we need a reference to the interface or connector. And then we want to know whether or not it's visible. So plugged in. That can stay as is. And then connector scale. We'll actually will link the scale to the voltage of the cable. More like it. Okay. And then, yeah, we're just going to have to go through each of these in turn. collapse this into a collapsed graph because this is going to get big. There you go, keeps that a little bit more more easy to work with. Okay, so we want interface 1 in, 2, 3, 4, 5, 6. Okay, so we'll just default that to 1 for now. And then we need to know whether it's connected, so plugged in. And then repeat until insane. So 2, 3, 4, 5, and 6. May as well do it like this because it's quicker. This is one of those things that it's a pain to set up initially, but once you've done it, it does make life easier in the long run. I shan't worry about those ones for a minute, but that should at least get rid of them. So as we turn those on and off, it gets rid of them as needed. And now they are visible. Alright, we'll get rid of them too. How many we got? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. One, two, Did I miss one or did I make a mistake? Oh, I made it. No. 1, 2. Oh yeah, I made a mistake. How very like me. Nine, 10, 11, 12, 13, 14. Almost there. So in the future, when I'm doing this, I think it might have been better to have held all of these in an array. So we'll just have like an array of booleans rather than like a specific variable for each one. But I suppose as much as it would make something like this easier, if we're trying to reference a specific cable, it is easier just to drag out a named variable. Yes, indeed. Yeah, the only like issue with looping it. So if we were to use get components, obviously there's more than just connectors as components. And then you'd need to make sure that each component was mapped against an array index, like consistently. You can do it by class, can you? That helps. But then you need to make sure that the array of components, the indexes, match the array of booleans. So from index to index, you need to make sure that they align. So I think probably the better way would probably be to add them all to a struct, and then use the struct instead of this. So basically condense all of this into a struct, including a reference to the interface. Would probably be the cleanest way of doing it, because then basically all of this just gets held in a single struct entry rather than having separate variables. But that would mean rewriting the whole thing, and we don't want to do that yet. But for future improvements, I think that's probably where I'd go with it. I'd use a struct. Yeah, it could do. But then it's like if you then rename it for any reason, then you're kind of digging a hole for yourself. But we can store a direct reference. Yep. Right, so they shouldn't be there. Don't need to do that anymore. That can just go in there. Just handling the box itself, so yeah, there shouldn't be anything else setting visibility on those. Thank you. Yeah, it's you do tend to get those days from time to time, don't you? Where like everything you try just goes wrong. But it's good. We endure. But like, why is that there? See, that's being set to visible. Even, oh no, 1, 2, 3, and 4 should be visible, but 5 should not be. Because, if we look at here, so number 5, plugged in is false. So if plugged in is false, then should not be visible. I mean, it's definitely working for this bit, so wrong bit, this bit. Yeah, so it's hiding and showing that, and those ones. So why not those ones? I'm assuming there must be a reference to it elsewhere. Let's have a look. Oh, is it this? So what's referencing that? There we go. Yeah, there was a conflict there, so that's fine. That's better. Just copy the location of that one to make life easier. So paste it there, move it down. Next one, paste it there, move it down. That one, same again. Okay, so we've got our outputs and our inputs where we want them. Oh, sorry to hear that, CSI. Let's hope for a better week next week. Right then. So with those ones in place, the next ones are these. I don't think we're mirroring it on the other side. No, so that. Group that up, and then that, and that. So that's battery feed 1, battery supply. So again, this is currently suboptimal because I'm simply exporting them at world origin for testing purposes. Don't want to be doing that normally. So there's those. Have a good one, CSI. Oh, was it genuinely your birthday, Delta? Oh, happy birthday for yesterday. Hey, Danger Mouse. I'm working on cables. Or at least we're starting the test of how we're going to route everything like properly in the Caravella. So we need to have a look at how much space we've got for certain cables, what kind of size they need to be, how they are routed from the reactor, and just generally all that stuff. So interface in, it's going to be that one. So that needs to overlap with that, so that they can magically work. If we copy the location of that, then we can speed up those ones. Should get, technically that should get all four of those working. That should now have power, so it should at least come on. And at the top here, I suppose we need to do the feeds. I guess we'll go up and over the ceiling with those ones. We'll stick in a back wall across here. Obviously that's the back of the ship. So we'll square the room off. I definitely would prefer to not have the batteries like located there, but there just really isn't anywhere else to put them. It's such a small ship that it doesn't matter where you put stuff, it's going to be near the outer hull. Why are you there? Okay, so yeah, so these are basically floor to ceiling racks. then we'll feed the power into the top of each rack as we go across. Do you mean like that? We can do that, but what I'll do is I'll set them up in that way anyway. So I'll do floor to ceiling housing for the battery arrays, and these ones need to be bigger anyway, to be fair. Like on the Magellan, they really look lost in the rooms, so they need to be, you know, bigger and take up more room than they do. Given that these are the batteries that are powering the entire ship, you know, they need to be a little bit more chunky and robust. Right, so I need to move our out interface up here for a minute. No, it's because they're not yet. So this was the beginning of the housing that contains the batteries. So the idea is that they're electrically insulated against the hull, and the batteries themselves sit in here with all the connectivity and everything going through. But they were never finished. Okay, it's got the wrong connector type, but it doesn't matter. Right, so there's that one. And that one. And so on, and so on. Actually, so that we can see those a bit better and make sure they're actually like working, to make sure that they are flashing at the end and physically connected. Let's see how far the electric's getting. The batteries are solid state, so whatever technology solid state batteries would look like. Right, so let's fix this reactor again. So right now, nothing. So we'll take our magic startup voltage. Start that off. Oh, yeah. Hit supply. Okay, so we need to debug that a little bit. And one assumes that means that these aren't working either. Yeah, Nothing. Well, fortunately, the game is set 200 years in the future, so hopefully we would have figured it out by then. So I suppose, actually, looking at this, we need to set up the actual widget itself. Let's just do some debugs on that a minute. So we know that we are getting our input connector. Or are we? Because we might not be. Let's just double check that. Input. Right. Oh yeah, we're not. So, so if the cable is plugged in, we don't need to be checking that often. So interface in component overlap. Yeah, I can't really macro this because we've got set references, so we can set a wildcard. But we'll see. Messy, but it'll do for testing. And then on this side, we need to do the same thing. So we take all of that and add all of that. before I do that, actually. No, we can't set that as a wildcard, I don't think. No. It's a shame. Because if we could set that as a wildcard, then we could grab that. Can we set that? There might be a way of doing that, actually. Because what I want to do is macro this. Take, I guess, take that variable, but set it as an input on the macro. So whatever we get there as our output, set that within the macro. Although I suppose we can just put that as the output for the macro and then set it there. Yeah, that makes more sense. Yeah, so what we'll do is that inside the macro and put that as our output. That makes more sense. Find connected cable. Which it's done for me. Right, now we'll tidy this up. So don't need that. That's our timer reference. That's our I always call them interfaces because ultimately I'm a network engineer. Anything you plug something into is always an interface. Breathe a bit now, it's not part of another graph. Okay. That should do what we want. So that's the component we're overlapping, that's its world transform, that's our object type. I guess that can just be cable, because this particular device is only connecting to cables. So is there a cable? If so, clear the timer and output that. Otherwise, spam some errors. If we get that instead, actually. Because we can grab the name from that, but if we grab a name to the device as well. Hopefully that error message will be meaningful if needed. Okay, that cleans that up nicely. So just need to do the same with all of these. In fact, I will just dump that and replace as we go. So interface to out, and then wherever the actor is, there, interface to actor. I think today's stream needs to be the tedious tasks stream. Because sometimes you just have to spend all day doing copy-paste. Okay, then I need to set references. So let's interface 3 out, cable 3. Four out, cable 4. And so on, and so on, and so on. Riveting stuff, I know. I did some of it today, funnily enough. The VR pawn that we spawn immediately before possessing it was not reporting that it was ready, so it was causing a black screen on VR, So basically the loading screen goes away, then you're just presented with a black screen of nothing. That I fixed today, so that's working now. And I spent all morning sorting out the representation of the sun flare that you see in space in VR, because it was offset on each eye. So basically you could see the disk of the star in the distance, but the actual bright flare was offset left and right of it, depending on which eye you looked through. So I needed to sort them out. And I also fixed like tilting your head, and what would happen, oops, wrong one, because I'm not paying attention. When you tilt your head, you were tilting the sun flare effect because it was aligned to the viewport. So it wasn't like a world aligned thing. Oh, did it again. I can't talk and do this at the same time. So yeah, so you tilt your head like that, then the effect on screen was like matching your head movements, which looked really stupid. So I had to fix that as well. So yeah, so a lot of the stuff with VR is just little stupid things like that. What do you mean in that? Oh, have I not connected it on one of them? But that's what it is. Yeah. Ah, that one. Right, so that has made that tidier. I will I suppose do the same over here as well. I'll just do the one, rather than going through and doing all of them again. Okay, much tidier. But what we don't have is a widget setup. Do we have a default one? So it's the DEX one we're using by default. So we're not actually configuring a screen. So let's do that. It's probably going to need a custom screen for now, at some point at least. Yeah, so we're setting it to 1 by 1 pixels to begin with. Again, just to save on VRAM. But what we do need to do is grab that and then set widget, and then see which one we actually need to give it. Assuming we're going to have a 1 in 4 out here somewhere. How many's on that one? Almost the same amount. Alright, we'll borrow that one for now. So basically, every UI has to have interface elements for the inputs and then the same for the outputs, with room for the data for each of those. So ideally it would be nice if we could generate this UI automatically. Each one of these is a separate widget anyway, so that's its own separate widget we're pulling in. So it shouldn't be too difficult just to cobble together another one. But I think I'll use that one for testing. So that's WBP. Oh, hang on then. Get widget set. No. What are we calling it? Set widget class. Oh, can we not do that? I was hoping we could swap the widget class at construction time, so that we can just make it a variable and pick which screen we want for it, but that doesn't seem to be exposed, unless I'm doing it wrong. Weird, because I'm sure that those are because it's a widget blueprint. I wonder if I make a variable for a widget blueprint, so we do an object reference on a widget blueprint. Can we get no. Interesting. So what's that? So that's a widget component. So we can't get the actual widget from there. I'm going to have to do some Googling on that, I reckon. So for now, we'll just use the one that's on there already. So what we need to ascertain is whether or not that box is getting the voltage we want it to get. to make sure this thing actually starts up on supply mode as well. Potentially an ASCII. I need to go through it. There's a few issues which I need to solve, which is always the way when making new stuff. Right, so we know that that cable definitely has power running through it. So it should be a thought occurs. I bet it's because our list of valid overlap classes doesn't contain the distributor. No. It does not. So distributor master tickable. And technically, for the most part, we shouldn't need to validate overlap class, because we are just like here. It's a component overlapping the component on there, so there shouldn't be anything else that it overlaps, but sometimes you never know. There could be some invisible thing like that light's got a box around it, and that box might be overlapping something, and they always catch you out. Anything, pretty please? So if we go back to startup, then yeah, so that cable is now dead, as we'd expect it to be. Go back to supply, and that's now showing voltage. It shouldn't be flashing, by the way. I know all the cables do flash at the moment, but they should just be a solid green and flash red if there's a problem. So I don't know why they're flashing green. I have to get to the bottom of that. Right, okay, so why is the box not doing what it's supposed to be doing? Right, so I guess let's check that we are actually getting a reference to that device, because that would explain it if we're not. Yeah, well, they're overlapping, so they should be able to sniff one another out. So we'll just see what that says if need be. So if that's green, then we are good. I guess the other failure state could be that it just literally didn't get anything. See what it says on startup a minute. Okay, it said nothing, so that would suggest that it's not getting an overlap. So let's do our valid index check so that we can be sure that we are actually doing what we're supposed to be doing. Pop that over there. So no overlaps. Actually, we'll put that one there. No class match. Let's make them a different color so that they stand out. Okay, so not seeing any overlaps on any of those cables. Obviously we've got a bunch of these. Well, I guess we've got 5, haven't we? So we've got 5 errors. And we've got 5 cables, so those 4 plus that 1. So we should be seeing an overlap there, and we should be seeing one there, and we should be seeing some there as well. So yeah, so all 5 of them are for some reason not overlapping what they need to. So we will just double check that everything is set to world static, because that would scupper us otherwise. No, those are set to movable, which they shouldn't be anyway. None of those should be set to movable. Let's check these two actually. So all of the static meshes on here should be static. And the scene should be static. Where's the what's it there? Same again here. So all of these everything's set to static. Scene should be static. That one is static, and so is that. So that's going to need the battery one as well. Basically, this array needs to contain every electrical device we have. Hey, League of Carnage. So that definitely was failing, wasn't it? Yeah. Okay. So I shall do the same on this one. Which one are you? Out. So that's downstream. Okay, there's no point with those because we're not getting that far. Helps if you plug it into the right thing. So world static. Don't care about class filters. Actually, I suppose the other thing we need to double check is make sure that the collision channels are set right on these. So that should just be block all. Same on that. All of those. For some reason they're set to volume. That's not going to help, is it? Hurrah! Right, we're getting somewhere. Our military ships will be quite pointy. This one's a science vessel, so it doesn't need to be too pointy. So it's definitely like that cable is definitely connecting to the distributor. So it's definitely sending voltage through. Let's see what the box itself is receiving. And let's see whether we can keep that reactor online. Are we not sending that? That would make sense. So blah 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 blah. Generate the galaxy. Blah 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 blah. Load save game. Do our ship startup. Yep. 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 Okay. So we are going through the usual steps. So the battery arrays don't need to be initialized right now because we're using just a fake voltage source for all the cryocoolers. So we can initialize all of that. In fact, let's speed this process up a bit. We kind of need to see from the reactor side, like, what does it think's going on? Yeah, so if we, oops, let's just do an output from this. We got coil temperature. And so HE3 flow. Then we got deuterium flow. And then we've got bus voltage. And then we've got wondering whether or not this could be a coils being too hot problem. So it's shutting itself down rather than continuing. I think that's what's happening. I think at some point during the startup, the reactor is going out of range on one of these values. But let's see. So that was out of range very briefly. Which is interesting, because it shouldn't have been out of range at all. Hang on, let's have that linger around a bit longer. So, so we've set all the temperatures there. Right, let's see what it actually says. Oh, we can get rid of that cable spam now, can't we? Because we know that that is working. Yeah, definitely in the zone. It's been one of those nights tonight, actually, where nothing has gone straight forward first time. It's all required messing about. Okay, so the problem is we're seeing no flow on the helium-3 or the deuterium. So our vacuum's looking good, our bus voltage is good, and our coil temperatures are good. But yeah, there's no flow coming in. And I would assume that also means there's no coolant flow either. Is that because... no, it can't be. I was wondering whether it's because they think they need to be powered by the reactor. They shouldn't need to be. Yeah, we're using fake power. They all are. Yeah, so they're all using fake power, so they should initialize immediately. These tanks are set to start empty. That can't help, can it? Bet that's what it was. Okay. Aha. Good. Right. So we don't need to start worrying about that now. So that's already set to supply. Got voltage going through. Great. So the reactor starts as we want it to. Let's get rid of that because I don't want any messages for any errors that aren't relevant. Now it was user error. I forgot, because we were testing all of this when we put all this in. Of course, we wanted to make sure the tanks were filling up properly, so I set them to start empty. So of course it's starting the game with empty tanks, which means the reactor is immediately turning off because it's not pulling any fuel. So mystery solved. But yeah, it was user error, and it's usually user error. Right, so we need to know now, why is this not doing the do? So I suppose the first question is, are we actually getting voltage? No, that's not that one. That one. Okay, so we should be seeing voltage coming in on interface A. I'm just going to actually, so I think I know what's happening. So my assumption is that the cable, of course, the cable doesn't know what interface it's connecting to. So when it sends the voltage report, it's sending that voltage report to the device. So where has it gone? So when this blueprint interface comes in, although is this one a cast? It should be blueprint interface. So that won't help either. So voltage delivery. Yeah, so that in itself is not going to be helping, because for some reason it's converted that to a custom event rather than this. Right, so when that comes in, obviously we'll have our voltage coming in, but we won't have an interface, so we won't know where that voltage is going, what port that's coming on. So the challenge with not pre-configuring this is having it know which interface the cable is overlapping, which is not straightforward. So I don't want to have to configure every single cable with a manual reference to the interface that it's plugged into on there, like here. So we're basically saying it's plugged into A. Now that one will and should work because it's already set to A. In fact, let's just test that a minute. In fact, let's just see if it actually says anything. It should just say hello. It did. So it said hello. So it got some voltage. So actually, if we go in and have a look. So it definitely received something because it said it did. The lack of a UI means that it's probably not getting voltage where it thinks it is. So if we do another debug till we get to the bottom of this. Right, so we've got our interface string, and then we've got our voltage that we're sending. Weird, where'd that vanish? Right, let's see what we're actually getting from the reactor. So it should be 100,000 volts, I believe. Obviously that's not what we'll actually be using for this particular box because it would explode. Okay, yeah, so interface A, 100 million volts. just a few volts. Okay. Right, so we know that's working. Okay, so just make sure that's working. So we want interface A voltage. So just make sure that we're actually reporting that stored in our replicated variable. And we shall remove the debug on here because I'm always forgetting I've left debug on. Hence this. I can't remember what that's from now. Okay, so it's saying 100 million volts on that interface, which is good. That's what we would expect to see. So blah 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 blah. Right, so let's see if we are getting an actual voltage on the internal bus. Basically, we're just stepping through each bit of the distributor code until we figure out where this is failing. So nothing, nothing, nothing. And still nothing. Alright, so the issue then is that the internal bus thinks there's no voltage. Okay. Actually, to print text. So we can track that there. So, right, where are we failing? So we know it's enabled. We know we have voltage. So we're just adding all those together. Or rather, we're taking the max of whatever those are. Obviously, when you've got a bunch of parallel cables all plugging into one unified bus, it's the maximum voltage of whatever one has the maximum voltage rather than the sum. So that's right. But it must be failing at that point. So this is true because we've already checked that. And that's definitely enabled. Or is it? That would explain it. So standard. Right. So its default state wasn't set. Right. Let's see what we end up with. So hopefully that will jump up to 100,000 once the reactor starts. Yes, there we go. 100 million even. Which means... Aha! Right, so now we have voltage out of the box. We still don't have a screen for some reason, but that might have to be a problem for another day. Do we have voltage on these cables? No. Okay, so getting there though. So we've got voltage leaving the device, but the overlaps are going to be not working on there, I suspect. Or no, that must be it. So yeah, it must be that the overlaps are failing on those cables. So yeah, all right. Okay, well we made some progress tonight, didn't we? Not the usual ploughing ahead with new stuff that we're used to lately, but yeah, we made some progress. So basically what's happening with this system is that we're taking our really difficult to configure clunky system and we're making it easier to deploy, so that we're relying on cables touching other cables rather than having to type in this cable connects to this cable and giving it IDs, because that's proving to be a logistical nightmare. So we do need to manage those overlaps, and so far we're getting there. So we just need to update the existing electrical system to support all of this new methodology. And then we can roll out the full electrical network on both this ship and the Magellan once it's all working. But yeah, so that'll be it for me tonight. I think I need to go and have a stretch, have a cup of tea, clear my head, and get cracking back into it again. I will try and get a dev build out later. I need to fix a problem with the pause menu. For some reason the mouse cursor is missing, and I don't know where it ran off to, but we've lost the mouse cursor, so I need to fix that, and then I can put a dev build out. I think that was it, so I shall see everyone on Wednesday for more Magellan class fun, and yeah, have a great week ahead. So see you on the next stream, and bye for now.